Hello, my name is Mark Turcott. I'm a visiting professor in the Department of Mathematics at the University of Texas in Arlington, Texas, in the United States. 我是 Mark 教授，在UT Arlington 大学的数学系。Today, I will be talking about means, ways to measure time, temperature, distance, and frequency. In this part of the lecture, I will cover these topics. In the other part of the lecture, I will cover the definition and difference between precision and accuracy. So today, right now, we will concern ourselves with how to make measurements of certain quantities. First quantity that we want to consider is time. How do we measure time? Everybody is familiar with the passage of time, but how do we measure how much time has elapsed, has passed? How much time? We use a device that's appropriate to the kind of measurement that we want to make. The first most common device that's accessible to students in a school laboratory would be the stop clock, which is a very simple device. It's a little box that has a clock in it and actuators on the top to start and stop it. Typically, such a device can be read to about 1/5 of a second. The second device that one can have access to is the stopwatch. The stopwatch, or the digital timer, typically can be read to about 1/100th, that is 1/100 of a second. Now, in all kinds of measurement where a human is involved, that is, an experimenter has to perform the measurement, an important concept is the so-called reaction time of the experimenter, which can be as large as a few tenths of a second. And notice that this is getting close to how well the stop clock can be read. And I'm not really, I'm not being very precise in the use of the word precision and accuracy right now, because that's something that, as I said before, we will explain later. So what is the reaction time of an experimenter? Well, let's give an example, very short. Let's say that I wanted to measure how much time it takes for a car to go from point A to point B. And I held a stopwatch, seems appropriate, in my hand. And I watched, and the car passes by point A, and I press the start button. Well, I have to notice that the car has passed point A. then I have to think I need to push the button. That amount of time is called the reaction time of the experimenter. So this reaction time is quite significant sometimes, depending on the process that one is interested in to measure. Okay. Another quantity that one may want to measure is temperature. In order to measure temperature, one usually uses so-called mercury in glass thermometer. What is that? Well, it's essentially a container, a long, elongated, thin glass container with a liquid in it. In this case, mercury, which is a metal. And the property of this metal is such that its volume expands when the temperature increases. So the level of the mercury rises because its volume gets bigger, but it's confined inside the thermometer. These devices are typically graduated from about minus 10 degrees C. Well, this pen is not working. Minus 10 degrees C to about 110 degrees centigrade. It can be read to about plus or minus 0.5 degrees centigrade, or sometimes even 0.2 degrees centigrade. What's another quantity that would, an experimenter want to measure? Distance. Distance is an important concept. We can measure distance with one of the simplest instruments to measure distance is the ruler, with the ability to measure to plus or minus 0.5 millimeters, typically, if it has a range of maybe 1 meter. So a meter ruler would have divisions every millimeter would be indicated on it. So you would be able to tell that something is between one division and the other. So you would be making a measurement to about 0.5 millimeters. But if you're interested in a more, and I'll use the word precise now, and then give me 5 minutes and I'll explain these terms more precisely. Then you might want to use a so-called micrometer screw gauge, which is a device that is built like a horseshoe, and it has a screw on the side, and it's graduated such that you can measure to about plus or minus 0.1 millimeter over a range of about 50 millimeters. And then, if you're interested in even more precision, then you might want to consider the vernier caliper, which is another device that measures to plus or minus 0.1 millimeter over a range of about 100 millimeter. Another quantity that we might want to be interested in measuring is frequency. And we might want to use a cathode ray oscilloscope. It's a little bit outside the contents of this lecture to explain how the device works, but it is it looks like an old-fashioned TV screen, and at the front of it is a display that shows you an XY graph. On the y-axis could be anything, actually. It depends on what the device is connected to. But for the purpose of example, it can be the voltage across a resistor, for example. And on the x-axis is essentially time. So if you are measuring an oscillatory signal, goes up and down and up and down like the sine wave, then you might be interested in measuring the frequency of that signal, in which case you would measure the distance, L, according to the units on the x-axis, from going from peak to peak, for example. And depending on the setting, or the so-called time-based setting on the oscilloscope, then the time corresponding to going from here to there is L times the setting on the scope. Then the frequency would be given by 1 divided by the time, the period. This particular time is called the period of the signal, period. So the frequency is 1 over the period of the signal. Why? Because it's periodical, meaning that it repeats itself one after the other. And the units are called hertz. Symbol is Hz. Not Hangzhou, but hertz, Hz. And in terms of units of workable units is 1 over second, so inverse seconds. Of course, the units of time are seconds. 谢谢。